So hi, this is Sandeep and you are watching Samyan's Academy, and in this session we are going to discuss about the chapter light from the class 7. So let us start. So light travels along a straight line. To perform this activity, so you have to take one candle and one straight pipe and one bent pipe, right? So light a candle and fix it on a table. So take a piece of the straight pipe like this or rubber tube like this and look at the candle through the pipe. So from this you have to look at. Can you see this candle? Can you see this light? When you see from this light, when you see from this pipe, yes, we can see. Suppose when you take the bent pipe, can you see the candle flame from this pipe? No, we cannot see. So you cannot see the candle flame. So this shows that light travels along a straight line. Okay, light travels along a straight line. Now here are the reflection of light. Then how we can see the objects, how the objects are visible to us? When you enter into the dark room, can you visible the objects clearly? Can you see the objects clearly? No, we cannot see, right? When so here what will happen, suppose here this bat is there, right? It's a yellow color bat. How we can see this yellow color? When light falls on this bat and the reflected light reach to our eye, then only we can see this object. What is happening here? The straight light which is coming from the light, so which falls on the this thing, and this thing get reflected light, so this will give the reflection, right? The reflected light reach to our eyes, then only we can see the objects. Means what is reflection? Reflection means bouncing back of light, we called as reflection, right? Bouncing back of light we called as reflection. So in this, when light falls on a mirror, the direction of light changes. This change in the direction of light by a mirror is called as reflection of light. Means, let us see this activity. So in that we have enlight the torchlight. The light of the torch, it is incident on this mirror at the angle 20 degrees. At the angle 20 degrees. This is a protractor. We have taken protractor. Okay. The light falls on this mirror at the 20 degrees angle, which is making with this line. Okay. This is a 0 degrees line, right? So how much angle is there here? What is the angle here? Yeah, let us say this is a normal line. Let us say this is a normal line. This is a normal line, right? The light falls on like this, right? So it is making how much angle? 20 degrees angle. Now you observe the reflected light also coming back with the same angle. What is the angle? It is 0, 10, 20. It is also doing same angle. Means the incident angle and the reflected angle, in this case both are same. Okay, angle of reflection and angle of incidence, here it is same. Now to know the reflection of light, so what we are doing now, when light falls on a mirror, the direction of light changes. This change in the direction of light by a mirror is called as reflection of light. Now you see, incident light falls from this side, but can you get the reflected light on the same path? No, we are not getting. So we are getting the reflected light from another path. From another path. Means here direction of light is changing, right? Here direction of light is changing. So when light falls on a mirror, the direction of light changes. This changes in the direction of light by a mirror we called as a reflection of light. Simply we can say that bouncing back of light also we can called as reflection of light. What is that? Bouncing back of light we called as reflection of light. Now you see, here we have an activity. Take a torch and cover it glass with a chart paper, having a small hole. Spread a chart paper on a wooden board. Keep a plain mirror vertically on it. Direct a beam of light at an angle to the mirror. So we direct a beam of light at an angle to the mirror. So how much angle we are taking here? 20 degrees angle we are taking, right? Then the direction of light changes. Can we get the same light on the same path? Reflected light? No. The reflected light is coming from the another path. Means here the direction of light here changes. If the torch is moved slightly like this to either side, the direction of the light also changes. When this light falls on this 40 degrees angle, then the reflected light comes from 40 degrees from other side. Means the angle of reflection and the angle of incidence both are always equal. Remember that one. Okay. So next one. So image formation by plane mirror. Here we have the 5 points. So image is a erect. Erect means we are not can you see your image like up and down? No, right? We can see our image like straight, head to head and tail to tail, legs to legs. If it is matching every part, each and each part, that is we called as a erect image. Okay, suppose a bat is there. So when you take this bat, when how will you get this image? Same like this only you will get the image. You are not getting like this image, right? Suppose suppose you are showing bat in this direction. So how will you get the image? You will get the image also in the same way direction. You are not getting like this, right? Means the image is not erect, image is not inverted. Image is erect means head is matching with the head, legs are matching with the legs, hands are matching with the hands. Okay, and here image is erect. The image is same size as the object. Now what is the size? Suppose it is having height, let us assume it is having the height 1 meter. Then how much size we can see on the mirror? Same size you can see. Means the image, the size of the image, the size of the object, both are same in the plane mirror. The image is same, the image is at the same distance from the mirror as the object is in the front of it. Suppose you stand about 5 meters behind the mirror, then your image also form the 5 meters before the mirror, means behind the mirror. Suppose you are standing before the mirror, how much distance you have stand here? 5 meters distance. Let us assume you are standing before the mirror 5 meters distance. Then where we can get the image? Image also you can get the behind the mirror after 5 meter. Means the image distance, the object distance, both are same in this case. Okay, from in the case of plane mirror. The image is virtual. Virtual means can we obtain our image on the screen? No, we cannot obtain image on the screen. If you are not obtaining your image on the screen, means like these images we called as what? Virtual images. Okay, and now in the image the right side appears left and left side appears right. For example, this is your right hand. In mirror you can see this your right hand as a left hand, left hand appears as right hand, and like this image we can get, and that type of images we called as laterally inverted. What is that? Laterally inverted. That like that images we called as laterally inverted. And what are the characteristics of the image formed by the plane mirror? The image is erect. And what is the second one we have here? The image size is, and the size of the image and size of the object both are same or not? Yes, and the distance of the object and distance of the image both are same from the plane mirror. The image is virtual. Virtual means we cannot obtain that our image on the screen, right? So the image is the in the image the right side appears left and the left side appears right. So like that images we called as laterally inverted. Okay, and we have here spherical mirror. Spherical mirror we have the two types. When you take the spoon, concave is there, so cave type structure we called as a concave. The other end, the other side of the spoon we can take as a convex mirror. Okay, cave means cave type structure we called as a concave. Concave means it is having the cave type structure, that is we called as a concave. Suppose when you take other side, back side of the spoon, it appears as convex lens. Now what is spherical mirror? Spherical mirrors are the curved mirrors. It is not straight like a plane mirror. Okay, spherical mirrors are the curved mirrors. If the reflecting is inside, the spherical mirror is we called as concave mirror. So what is a concave mirror? If you are taking the reflecting surface is inside like cave type structure, and that type of spherical mirror we called as concave mirror. Okay, and if the reflecting surface is outside, the spherical mirror is a convex mirror. Means the other side of the spoon we can take as a convex mirror. This side this side we called as a concave. It is a cave type structure. The other side when you see like this surface look like as convex. This is a curved shape, right? If reflecting surface is inside, that is we called as a concave. If the reflecting surface is outward side like this, so like this like this surface we called as convex. Okay, how many types of spherical mirrors we have? The convex mirror and a concave mirror. Concave means the reflecting surface is inside the mirror and inside the spherical mirror is called as a concave mirror. If the reflecting surface is outside, like that spherical mirror we called as a convex mirror. Now you see here we have the stainless steel spoon and also which acts like a mirror. The inner side acts like a concave mirror. Okay, the inner side of the spoon acts as a concave mirror, the outer side of the spoon acts as a convex mirror. Okay, now a stainless steel spoon also act like a mirror. The inner side act like a concave mirror and the outer side act like a convex mirror. Now you see this is the spherical part, this is the sphere. Now we have drawn two mirrors. Concave mirror means the reflecting surface here inside the mirror, inside the spherical part, inside the spherical, this is the spherical, the reflecting surface is inside of the spherical mirror is there. Means when you take the reflecting surface here, the reflecting surface is outside of the spherical mirror, outside inside. Is it clear now? Now this is the sphere, let us assume this is the sphere. Okay, so let us assume this is the sphere, right? This is the sphere, this is inside of the sphere, right? This is the inside of the sphere which is outside of the sphere. Okay, if you have the reflecting surface inside of the sphere like this, now you see this is having the inside the reflecting surface having the inside the sphere. Such type of mirrors we called as a concave mirror. If the reflecting surface is outside the mirror like this, outside the mirror, and such type of such type of mirrors we called as a convex mirror. Is it clear everyone? What is a concave mirror? What is a convex mirror? Now you see this is the outside, the reflecting surface is outside the mirror, it is, which is called as a convex mirror. If the reflecting surface, if you have the inside the mirror, which is called as a concave mirror. Is it clear everyone? Right. So now these are the spherical mirrors and which are we called as curved mirror. Next, image formed by concave mirror. Activity, you have to take this concave mirror and place the mirror at these places. Object is, when you keep the object is very far, when you keep the object is very far and image is obtained at f. You see here we can see the small image, right? When you keep the object very far, here we can see the small candle light. Have you observed this? Yes or no? Yeah. Okay. So when you take the candle nearer to the concave mirror, so when you keep the object is at very far, so the rays, the reflecting rays meet at here at f. So we can see the image here. At the case 2, when you keep the object at C, beyond C, object beyond C, then where we can see the object image we can see at f. Now you see here we can see the image, right? So this image we can capture on the screen. Clear? Now when you place the object at C, you will get the image also at C only. Okay, when you place the now when you keep the object beyond C, you will get the image between C and F. Inverted image you are getting, small size image you are getting. When you keep the object at C here, at C, so in this case you are getting the image also at C only. Here you will get the same size of the image. Okay, here's the size of the object and size of the image, both are same at C. Now you see we can capture on this screen that image. Okay, when you keep the object at C, you will get the image also at C, but you are getting the inverted images, inverted and same size image you will get. Okay, when you take the candle very nearer to the C and F like this, you will get the image beyond C. Image is formed beyond C. The size of the image is enlarged here. The size of the image is enlarged. Okay, like this. So object when you keep the object between C and F, so where will you get the image? You will get the image beyond C. What is the size of the image? This is the enlarged. In case 5, when you keep the object at F, you will get the image at infinity. It's an enlarged image you will get. On this paper you will get. So are you able to see this? Yes, yeah, the candle flame are you able to see on this paper, right? When you take very nearer to this candle, here we can see the image. So this image we can capture on the screen. Okay. So for case 5, when you place the object at F, where you are getting the image, the reflecting rays meeting it very far, so you will get the inverted enlarged image. You will get like this. When you keep the object very nearer to the convex lens between P and F, when you keep the object, then you will get the image behind the mirror. Behind the mirror means inside the mirror. No image is obtained on this in this case. You will get the reflected light image only in the mirror. Behind the mirror you will get enlarged image. You will get when you keep the object very nearer to it, you will get this image on behind the mirror. In the mirror you will get that image, not outside the mirror. We get this type of images we called as virtual images. What type of image it is? Virtual image, right? Is it clear? Okay. Okay, now you see image formed by concave mirror, right? The image formed by concave mirror, it may be smaller or lighter. So when will you get this lighter image, smaller image? When you place the object very far from the mirror, you will get the very smaller images and inverted images you are getting. Such type of images we called as real images. Real images are inverted images, remember. Okay. When you take the candle nearer to it, then what happens? When you take the candle nearer to it, the size of the image enlarge. Okay. The size of the image you will get here, enlarged image you will get, and the image nature is inverted images, and you will get the real and inverted images. The image we can capture on the screen, right? When you take the candle very nearer to the concave mirror, so we can see the virtual image. Virtual images means we can see that images only in the mirror. Behind the mirror only the image formed, right? Now move on to the next one. So where we can use this concave mirror? Who will use this concave mirror? Dentist, doctor. Dentist can use this to see the cavity in the teeth. We can use this concave mirror. So concave mirror are used as a reflector in the torch headlights. So in torch headlights also we are using this concave mirror, and concave mirrors are used by dentists to see the enlarged images of the teeth. When you keep the object very nearer to it, so we can see the enlarged images. Okay. And concave mirror are used by doctors for examining eyes, ears, nose and throat. Okay, is it clear? Next, image formed by the convex mirror. So this type of images we are used as vehicle side mirrors. Okay. And convex mirror we used as vehicle side mirrors. And what is the advantages of this convex mirror? It can cover the larger area. It can cover the larger area, so we can see the larger area behind our vehicle, right? And we can see the smaller images here compared to the object size, the size of the object. Here we can see the smaller images. Okay. And the big bus also look like as very small in this mirror. Okay. And the image formed by convex mirror is always virtual and we cannot be obtained on a screen. We can see in the mirror only, right? The image is smaller in the size than the object. Already they here given the image is smaller in size than the object. Uses of convex mirror. Where we can use this convex mirror? Convex mirror are used as vehicle side mirrors in cars, scooters, any vehicle. Convex mirror has a wider view to help drivers to see the traffic behind them. Okay, to see the traffic behind them, they are used as a vehicle side mirror. Okay, these are the uses of concave mirror and convex mirror. So where we can use the concave mirror? Yes, where we can use the concave mirror? Yeah, so the dentist can use the concave mirror to see the enlarged teeth. Okay. And where we can see torch lights, headlights. Yeah, this convex mirror we used as a rear view mirror, not concave. Okay, which one we can use the which one we used as a rear mirror for vehicle? Side mirror. That is the what type of mirror it is? Convex mirror. Convex mirror we used as a vehicle side mirror. Concave mirror we used as a vehicle. No. Concave mirror we used to see the enlarged images. The dentist can use this, right? And also we are using in the torch headlights and vehicle headlights, we are using the concave mirror. Okay, and right. So lenses are how many types? Two types. What are those? Convex lens and a concave lens. Okay, convex lens is a thick at the middle and the thin at the corner. Now you see here we have two types of the mirror. So this is the convex lens, right? So this type mirror we called as a convex mirror. Okay. So convex is here, we can see this convex. Both side is having a convex shape. When you join this, you will get the convex lens. Convex lens is thick in the middle and thin at the edges. Now you see here it is a very thin here. This case, in this case here in between we can see the thicker one, right? Now you see convex lens is thick in the middle and thin at the edges. A convex lens bends light inwards. Means suppose when light is passing through this convex, then what will happen? Now you see the light bends towards inside, right? Like this. They are meeting at F. Okay. Means, yeah, when you use the convex lens, the light which is passed through the convex lens, it bends inwards. Like this, it bends inwards. So it is called as converging lens. Converging means all lights are meet at one point. This is we called as a converging light. Converging light. Okay. And which one we can use as a converging lens? Convex lens we used as a converging lens. What is mean by converging light? Converging light means when light is passing through this convex lens, the light bends and meet at certain point. Okay, and that's for that reason we are calling this converging lens. Okay, and when you take about the concave lens, where we can see the thin and thick here. Ah, yeah. So like a middle. You when you see the middle at this middle point, here we can see the concave lens is thin here, right, in the middle. Where we can see the thick edges, where we can see the thick at the edges. This is the edge. So here we can see the thick edges. Here we can see the thick edges. Where we can see the thin in the middle. But is a quite opposite to the convex lens. Okay. Whereas in the case of convex lens, the which one is thick here? Middle part is thick. Here middle part is thin. In case of concave lens, okay. Edge you see here edge part is very thin, but here edge part is very large, thicker. Okay, you have to remember this. Okay, a concave lens is a thin in the middle and thick at the edges. Now you see a concave lens, when light is passing through this concave lens, what will happen? You see here what will happen, the light get diverge, means it is going to be separate like this. So it is bending outward direction. The light bends outward direction. In case of convex, the light bends inward direction, but in case of concave lens, the light bends outward direction, right? A concave lens bends light outward, so it is called as diverging lens. Okay, which one is the converging lens? Convex lens is the converging lens. And which one is the diverging lens? Concave lens is a diverging lens. Is it clear, everyone? Right. Okay, now move on to the next one. Yeah, image formed by convex lens and image formed by concave lens. Image formed by convex lens and behaves as concave mirror. It is lens, not mirror, right? It is lens. This is lens, and it behaves as concave mirror. Convex lens behaves as concave mirror. Concave lens behaves as convex mirror. Okay, we are talking about lens, not mirror, right? So this behaves as, it is cave, right? So it behaves as convex mirror. Okay, remember, convex lens behaves as concave mirror. Concave lens behaves as convex mirror. Okay, whatever we images we got in case of concave mirrors, the same thing we will get in case of convex lens also. Okay, the image formed by convex lens, it is not mirror, so it is lens. Convex lens may be smaller or larger than the object. The image may also be real. In case of concave mirror also, we are getting two types of the images, real images and virtual images, right? So in case of convex lens also, we will get the same type. So real images, virtual images. Real images which can be obtained on a screen, and virtual images cannot be obtained on a screen, right? The image may be inverted or erected. Okay, real image, all real images means all real images which you are captured on the screen, it look like as inverted images. Okay, all virtual images are erect images. Virtual means we cannot capture on the screen. Next, image formed by concave lens. This concave lens behaves as convex mirror. Where we can use the convex mirror? We can use it as a vehicle side mirror. Remember, convex mirror we used as a vehicle side mirror, and this convex mirror and behaves as, sorry, concave lens behaves as convex mirror. The image formed by convex mirror is virtual, cannot be obtained. You have to use your not convex mirror. So here you have to use concave lens. Okay, the image formed by concave lens is virtual, cannot be obtained on a screen. The image is smaller in size than the object. Uses of lenses. Where we can use these lenses? Lenses are used in spectacles, microscopes, telescopes, and cameras. Okay, in that cameras also we are using the lenses. Okay, shooting cameras, right? And on mobile phone also we are using the lenses. In mobile camera also we are using the lenses. Okay, and these are the some uses of convex lens. Remember, don't get confused. Convex lens behaves as concave mirror. Concave lens behaves as convex mirror. Okay, you use concave mirror. Who can use the concave mirror? Dentist can use the concave mirror to see the enlarged images. Okay, in case of concave mirror, we are getting the real images and also virtual image. In the same way, in the case of convex lens also, we are getting the real images and virtual images. Okay, real images means we can obtain on the screen. Virtual images means we cannot obtain on the screen. And real images are always inverted. Virtual images are always erect. Okay. Now, in case of concave lens, now you see concave lens behaves as convex mirror. Concave lens behaves as concave. Uh, concave lens behaves as convex mirror. Where we can use convex mirror? We used as a vehicle side mirror, right? Side view mirror. The image formed by the concave lens is virtual and which cannot be obtained on a screen. The image is smaller in the size than the object. Okay, and uses of the lens, where we can use these lenses? In spectacles, microscopes, telescopes, cameras, etc. Up to here clear, everyone? Right. Now sunlight or white light or color. Now, have you seen the rainbow anytime? Now a rainbow is usually seen in the sky after a rain when the sun is low in the sky. A rainbow has 7 colors. They are red, orange, yellow, green, blue, indigo, violet. And to remember this, you have to remember this sequence VIBGR. Do you know this? Violet, indigo, blue, green, yellow, orange, red. Okay. When do we can see this rainbow? A rainbow is usually seen in the sky after a rain when the sun is low in the sky. Okay, a rainbow has how many colors? 7 colors. What are those? Violet, indigo, blue, green, yellow, orange, red. Okay, this rainbow has how many colors? 7 colors, like this, right? So to know this activity, so you take the glass prism and allow a narrow beam of sunlight to fall on one side of the prism. Keep a screen on the other side of the prism. We can see that 7 rainbow colors on the screen. This shows that sunlight or white light is a mixture of 7 color. Now when you pass the sunlight means sunlight is in which color? Sunlight is in white color. When you pass this white color through this prism and the sunlight disperse means split. The sunlight split into how many colors? 7 colors. On the other side of the prism we can see these 7 colors from violet to red. Like this we can see VIBGR. Okay. Now this is about sunlight white color. Okay. Now move on to the next one. Mixing the rainbow colors produces the white light. Okay, means from the white light, and when you split the white light you will get the 7 colors, right? When you mix all 7 colors with GR, again you will get the white light. Okay, the same activity, when all these 7 colors, you take one more prism, like inverted prism you take. So when you place like this inverted images, inverted prism, so when you pass all these rays, all these colors from that inverted prism, and all lights combine and form as a white color sunlight. Okay. So from this white light only we are getting all these colors. Okay. When white light split into 7 colors, you can see this VIBGR. Okay. When these 7 colors combine and give as a one color, that is white light, right? Now you see. So to perform this activity, here also we have an activity. In the 7 rainbow colors are mixed together, it produces white light. Take a circular cardboard and divide it into 7 segments. Paint the 7 rainbow colors on it. Make a small hole in the center of the disc. Fix the disc on the tip of a refill of a ball pen. When the disc is rotated fast, the colors get mixed and appears as white in color. The disc is known as the Newton's color disc. You take the disc and you paint all 7 colors on this disc. Okay, you place this disc on one small pen hole and you rotate it very fast. Then these 7 colors appears as white color. All these 7 colors, when you rotate fast, what will happen? It will appears as white color. Means when you mix the all 7 colors, it appears as white color. Okay, when you mix all rainbow colors, then it will appears as white color sunlight. This is your chapter light. Thank you for watching. If you like this video, please subscribe, share, like and comment, and don't forget to subscribe. Have a nice day. Bye.